Hey guys, now we're going to start to see how, a little bit at least, how it's going to come together here with what we've been doing over the past couple of days. So here we're looking at trig values from a point. So this is where we're going to change our SOHCAHTOA acronym to something else, just based on the fact that we're dealing with trigonometry on a Cartesian plane, right? Putting the two of them together. So first thing we're going to do is sketch the angle in standard position whose terminal side passes through the point 2 and 3. So we'll plot that. That won't be too complicated. 2 and 3. And then I'm going to draw a ray from the origin. Okay, and then of course what we're dealing with is right here. And so moving over, I'll go back and forth here. It says, write the coordinates of the reflected images of the point P for each of the other quadrants. So we've dealt a little bit with reflections already. So basically what we're going to do is we're going to deal with the mirror image of it in quadrant 2. So we're going to fold it over the y-axis. And it doesn't need to be drawn or anything. So in quadrant 2, that point would be -2 and 3. Quadrant 3, we know that both coordinates are negative, and quadrant 4, 2 and -3. So that's all we need to do with that. We don't have to do that all the time, but that's one of the things we need to do. And then last thing before we start getting into it, it says calculate the distance r between the origin and the point 2, 3. Leave your answer as an exact value, so that means we're going to leave it in radical form. Where possible. And so what we need here, and I'm going to draw it on the other one as well, is we're going to have a new Pythagorean theorem formula, right? So we know that this is 2 and this is 3, and r is going to be our hypotenuse. And that the r really deals with Precalculus 30, that's where the r comes from, but it's not really a huge deal for us. And so our new formula then will be x squared plus y squared, x and y being our x and y coordinates. So not necessary to do that, but I am going to do that for what's coming up next. So 3, so 2 squared plus 3 squared equals r squared. We'll take the square root of both sides, and r is the square root of is root 13. Oh, there we go. So that just gives you a little bit of a basic idea, and we're going to do a couple more here, because now what we want to do is figure out the primary trig ratios. So it says determine the value of the primary trig functions of angle theta whose terminal side passes through 3 and 4. So we're going to start with something pretty simple here, dealing with the first quadrant. So I find a picture is helpful. 1, 2, 3, 1, 2, 3, 4. And it is super important to have a decent understanding of this, just based on what's coming up next. So there's that one. And so what we have here, right, we have this is our x, and this is our y, and this is our r value right there. So we need to figure out x, y, and r. So x is 3. Y is 4, and r we need to figure out the same way we did before. So 3 squared plus 4 squared equals r squared. 9 and 16 is 25, taking the square root of both sides. So we have a Pythagorean triple here, right, where they're all natural numbers. So what we're used to, and this is where I'm going to switch it up for you, right, we're used to sine being the opposite side over the hypotenuse, cos being adjacent over hypotenuse, and tan being opposite over adjacent. Well, now we have different variables here, right? And so what we're going to do now is we're going to look at these ratios, and we're going to translate these into our x, y, and r numbers. And so sine of theta is opposite over hypotenuse. So now our opposite side is y, and our hypotenuse is r. So it's going to be y over r. Cos is adjacent over hypotenuse, so x over r. And tan is opposite over adjacent, so that's y over x. And so here are our new, here's our new acronym. And there's probably a couple of different ways, but I've heard this one pronounced as cirkix. So that's a way for you to remember that. And so now what we can do is we can take our values, so our y over r, right? They're all right there, so not too complicated. 4/5, 3/5, and oh, can't quite see that, 4/3. So just dealing with the sign patterns, because when we're only in the first quadrant, of course, we know that they're all positive. And it's kind of, this is one of my favorite things to do in this course anyhow. But it does take a little bit of thought process. So when we're dealing with a point in the first quadrant, right, our x, our y, and our r will all be positive, right? Because we know that, because we're in the first quadrant. So then that means that all three of these ratios will be positive. Because no matter what we take when we divide them, right, we'll end up with all positives. When we get to the second quadrant, we know that our x-coordinate will be negative, because we're on this side, right? X-coordinate will be negative, y-coordinate will be positive, and so will this. So now we want to figure out, okay, so what does that do for our sign ratios? Well, sine is y over r, so that positive divided by a positive, right? Cos is x over r, so negative divided by a positive is negative, and tan is y over x, so then we have another negative. Hope I'm not going too fast. Okay, moving over here. When we're in the third quadrant, both x and y coordinates are negative. R is always positive, right? You can't have an r value be negative. So then if I follow those same sine equals y over r, we get negative. And then x over r, we get negative, and then y divided by x, we'll get a positive. And then last but not least, here this time we have an x coordinate being positive, negative, and positive. So y over r is negative, x over r is positive, and tan is negative. So that just gives you an idea, and you can see that they're all positive in quadrant 1, sine is positive in quadrant 2, tan is positive in quadrant 3, and cos is positive in quadrant 4. So last example for the day here, it says determine the value of the primary trig functions of theta whose terminal side passes through 7, -9. Show your work and leave answers in radical form. So this is just basically, when I do this is just to kind of give you kind of a little bit of a, I guess, visual of what we're dealing with, right? So it doesn't need to be drawn to scale or anything. So I put my point kind of down there, and I'm just going to draw it here, pull it out, otherwise I don't have enough room. So just bear with me here. Okay, so that's what I have going here, and then that point, which I didn't end up putting in the spot where I originally had it, is that. So we have our x and our y, and now we need to determine our r value. So we'll start with that. So x is 7, y is -9, and r we need to determine, right, with our x squared plus y squared equals r squared. So we'll have 7 squared plus -9 in brackets squared, 49 and 81, which is not a normal number at all, but it is what it is. Excuse me. So r is root 130, but now we have our values. There we go. So now we're ready to do cirkix or ticks, right? So and it doesn't matter which one you do first. So whether it helps you to put the formulas in, right? So sine equals y over r, and so we look back and we go, okay, there's y and there's r. Are we allowed to leave a radical in the denominator? No, we're not. So I don't need to see this step, but of course this is how we rationalize the denominator from way, way back when, right? And so sine theta equals -9 root 130 over 130. Isn't that pretty? Cos is x over r, and so now we're going to do that. And so because our denominator is the same as before, right, we're going to multiply that by root 130 over root 130. which, like I said, I don't need to see there. And then cos theta will be 7 root 130 over 130. And last but not least, tangent is y over x, and that's -9 over 7. And that's it.